Okay, let's look at an example. Let's reduce 8x cubed minus 8 over 4x squared plus 4x minus 8. According to the rule, to reduce algebraic fractions, first of all, we completely factor both numerator and denominator. So I'm going to come out to the side and I'm going to completely factor the numerator. So we have 8x cubed minus 8. And I want to completely factor that. I want to completely factor 8x cubed minus 8. What I need to do first is to divide out the common factor of 8. So if I factor out the 8, I'm left with x cubed minus 1. Now I have the difference of two cubes. So using the formula for the difference of two cubes, I get 8 times x minus 1 times x squared plus x plus 1. Remember to factor the difference of two cubes. The cube root of the first term is x. The cube root of the second term is 1. The sign agrees. Now to get the other part, is x times x is x squared. X times 1 is x. 1 times 1 is 1. This sign and this sign must be opposites. So these two signs must be opposite. If this one is negative, then this one must be plus. The last one is always plus. So I can write 8x cubed minus 8 as 8 times x minus 1 times x squared plus x plus 1. So I have completely factored the numerator. Now I want to completely factor the denominator. I'm going to do that out to the side as well. So we have 4x squared plus 4x minus 8. Again, the first thing I do is to factor out the common factor, which is 4, which leaves me with x squared plus x minus 2. 4 into 4x squared is x squared. 4 into 4x is x. 4 into 8 is 2. Now I must use guess and check. This tells me my signs will be different. The only way to get x squared will be x and x. And I can get 2 by using a 1 times 2. X times x will be x squared. That will be plus 2x minus 1x is plus x. And negative 1 times the positive 2 is negative 2. So I can factor 4x squared plus 4x minus 8 into 4 times x minus 1 times x plus 2. So we have 4 times x minus 1 times x plus 2. Now once we completely factor both the numerator and denominator, then we divide out the common factors. X minus 1s are common, so I can say that x minus 1 divided by x minus 1 is 1. X minus 1 divided by x minus 1 is 1. I can also say 4 goes into 4, 1. 4 goes into 8, 2. And that's all I can do. The third step says give the answer. So if I multiply the 2 times 1, I have 2 times x squared plus x plus 1 in the numerator. In the denominator, I have 1 times x plus 2, or just x plus 2. So I write as my answer 2 times x squared plus x plus 1 over x plus 2. Now I want to prove something for you involving signs. Note that a minus b is equal to negative 1 times b minus a, which is really just the opposite of b minus a. Let's look at the proof. A minus b can be rewritten as a plus the opposite of b by the definition of subtraction. I can use the commutative property of addition to rewrite a plus the opposite of b as the opposite of b plus a. Now I can use the identity of multiplication to rewrite it as a negative 1 times b plus 1 times a. Now I can divide out a negative 1. A negative 1 into a negative 1b is b. A negative 1 into a positive 1a is the opposite of a. And of course I could now write that as the opposite of b minus a, because 1 times b minus a is just b minus a. Now I will be using this property quite a bit when I do reduction, as the next example illustrates. Let's reduce x squared minus 10x plus 25 over 25 minus x squared. Now the first step in reducing is to completely factor both the numerator and the denominator. X squared minus 10x plus 25 factors into x minus 5 times x minus 5. Notice this sign tells you the signs will be alike. This one says they'll both be negative. The only way to get x squared is x times x. I have two ways of getting 25, 5 times 5 or 1 times 25. The one that works is 5 times 5, because notice that would be a negative 5x plus a negative 5x is a negative 10x. 25 minus x squared is the difference of two squares. So I can factor it as 5 minus x, the square root of 25 is 5, the square root of x squared is x, times 5 plus x. So it's the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Now what you want to do is to divide out common factors. But I really have nothing in common. Not exactly. Now that's where my theorem comes in. Notice what my theorem says. A minus b is the same as negative 1 times b minus a. So what I can do is I can turn the 5 minus x around. So I can write it as the x minus 5 times x minus 5 over a negative 1 times x minus 5. So I've taken the 5 minus x and I've written it as a negative 1 times x minus 5. A minus b is a negative 1 times b minus a, based on the theorem I've just proven for you. Now by the commutative property of addition, 5 plus x is the same as x plus 5. Now what I can do, I can divide out the x minus 5's, because they're now the same. So I can say x minus 5 goes to x minus 5, 1. X minus 5 goes to x minus 5, 1. Now I'm left with x minus 5 over a negative 1 times x plus 5. X minus 5, negative 1 times x plus 5. Now since a positive divided by negative is a negative, I can write my answer as the opposite of x minus 5 over x plus 5. Again, the reason for this is a positive divided by negative is negative. In fact, I want to give you a note that you need to know that we'll be using quite a bit.